Well, welcome everybody. My name is Don and this is Jeff.
Sure.
And we're here today to talk about plant layout design. We're going to get into a little bit with some of the stuff where you can scale off of plant layout design, but mainly it's going to be about plant layout design and using it to manage large assemblies. How many people work with large assemblies here today? Okay, sure. How many? And then I assume they got people that raise their hands are SolidWorks users, correct? Or how many are SolidWorks users? Okay.
Anybody do plant layouts? Good.
Anybody been in a plant?
Anybody been to
All right. So Jeff and I are going to talk to you about that, and mainly what we're going to show you is just a different way to try to accomplish your task with less hassles. Just another tool that you have that you can put in your toolbox if need be to do what you're looking to do at a more efficient manner. Okay?
So a little background. I'm Jeff Linderman, as the thing says, with GoEngineer and AE with GoEngineer. I've been with 8 years. Prior to that, I was in the injection molding industry for 30 plus years. So I do the injection molding simulation tools, but I also cover this DELMIA Factory Flow and Plant Layout Design because part of my background in the injection molding industry was actually setting up plants and doing the workflow and doing the flow through the plant. So got me interested in this. That's when I started working with Don with the DELMIA products. So a little bit about you.
Sure. Yeah, I'm Don. I'm from Wisconsin, if you haven't noticed my voice. So I'm from Wisconsin, and I grew up, probably my first introduced to manufacturing was when we purchased, when a new implement or something was purchased for the farm, my job was to take off all the guarding. So I did that, took off all the guarding or improved it. And one thing I learned early is when someone tells you not, or to take all the hay out of the hay baler before you start welding, because you start yourself on fire. Listen to that. So, with that, so I've been all around manufacturing my whole life and in engineering as well, but then more in the manufacturing. So I've been doing this quite a while, from CNC to all kinds of different shop floor. Also like as a factory, almost like a shop engineer. So engineering and the shop gets along, which is a very hard task to do, right? So been around all of it for quite a while. So great. So what is plant layout? So plant layout design is in the DELMIA branding, and what this allows you to do is it's a 3D experience role that allows you to manage CAD data. So when I say CAD data, it could be 2D, it could be 3D, it could be point cloud data. We have customers that work with all three, and we can work with all three together in one layout. So we can have sketches, we can have 3D models, we can also have the 3D point cloud data with that. What it allows us to do is we can manage all of that, and we can manipulate what we want to do. We can do what if scenarios, we can move everything around that you have. So a lot of it, what this is it's meant that you're going to have some kind of data to import. So that could be 2D, 3D. It doesn't have to be SolidWorks. It could be a big term that we use in the DELMIA form is CAD agnostic. We get your CAD in. We don't care where it came from, essentially. So we're good with that. And then also with that is when we use it, when we find different scenarios for the plant layout, you'll see in here it's very ease of use when you get a large equipment that can be very troublesome when you're in SolidWorks or some other systems that it's slow. This is very fast, it's very sleek, and very efficient.
All right. So what we're going to look at in plant layout, we've got if you're familiar with SolidWorks and what's new stuff, the OMAX. This assembly has over 5,000 some odd components in it. Imagine taking that into a facility and having a production line with 12 of them. And you're trying to do this in SolidWorks. Not only that is you have a robot and or 4 robots, or you have all of these options in there, and some of these things have kinematics, and trying to do that in SolidWorks with huge assemblies is going to take a while. You start losing graphics and ability to work with the things. So our story is we're going to bring in 3 of these OMAX machines. We're actually adding a additional production lines to the system. So 3D Experience works. This is how we bring all these things together. So what we're going to do here with 3D Experience works, we're looking at design and engineering, all the different simulation, manufacturing, production, governance.
Yeah, which is all scalable. You can start in one section, but they all work together overall. So later on, if you decide you need more of this, all is completely scalable based on your needs. And also how it's licensed to. You could have it scaled for certain projects that you do, and then don't need this anymore. Maybe you're building a new facility and you want to figure out before you buy anything how you're going to lay it out, and then maybe that takes you a year to figure out, half a year. That's something then you can then use something else if you need to. But it's very, very useful for that. But again, it all ends up working together, even with DELMIA Works, which is the ERP and MES system as well.
Right. I think Dassault owns DELMIA. They own SolidWorks. They own Abacus, all of these other tools. So the 3D Experience platform is how they're bringing all these things together. So you have access to all of these. So there's simulation tools in there that are based on Abacus, everything else. But we're looking at DELMIA and SolidWorks. Like I said, the OMAX has over 5,000 parts in the components, but how do we get these things over into the platform, right? So we have SolidWorks to the 3D Experience connection. There's Design with SolidWorks, which is basically a connector for SolidWorks going into 3D Experience. And then there's also SolidWorks Connected, which is SolidWorks that you get when you get the platform. So it is still native SolidWorks installed on your computer. It's not web-based, browser-based. But either one of these works the same way, basically. Once you're connected to the platform, you have in your task pane to the right, this is where you control your PLM stuff and you save your data to the platform. So we have our 5,000 part OMAX into the 3D Experience platform. Everything's saved into it, and then we can move on. So you want to cover the different subjects?
Yeah. So DELMIA manufacturing. So there's a lot of different areas, subdisciplines inside here. So we have fabrication, robotics, virtual factory, and manufacturing communication. What we're kind of going to touch on is the virtual factory part of it, but more of the layout, the early stages of it, and get into layout where you need to have it. But Jeff had in a previous slide before, where he had a bunch of other areas, we can then, if we program robots, we have the robot programmer, those kind of things, we can then bring that information into here and use that for here. So if we create any home positions or end positions for dropping off, like parts from one station to another, we can use those positionings that are done in the robot programmer in our virtual factory to do that and show the simulation of that, which we'll show a little later on that.
Have that in there too. All right, so our DELMIA 3 Experience roles and applications that we're using on this one. The Factory Simulation Engineer is the role, and inside that role we have Plant Layout Design, drafting, and there's also the Factory Flow Simulation, which I'll show some of that as well, because that's fun and cool. So first we'll talk about Plant Layout Design. So what it's going to do is enable us to easily create our layout design for a manufacturing plant. Remember, this plant, we already had 3 existing work cells. We're adding a 4th to it. So we can see in that picture, we've got those set up. So our next one, what we're going to do is utilize existing data. Our existing data was the OMAX machine. We have the robots. We have some other parts that are in a catalog. And then that allows us quick startup time and a lower start cost. So how do we start plant layout design? We start with the compass. So our compass is where you start in the 3D Experience platform, if anybody uses the platform, right? So that's where you start. And then we're going to select the native application. What's a native application, Don?
So a native application is essentially, think of it as what we like to call like the main, so if you compare it to SolidWorks, it'd be like SolidWorks, and then all these other buttons you see are like weldments in SolidWorks, and then it's like sheet metal. These are all these other functionalities that you can do, and these roles that we have with these applications come with all these different things that you can use based on what you're trying to do, but they're all included with actual plant layout design.
Right. So there's native apps and there's also widgets. Widgets are web browser based. Native apps actually install on your computer as well. So now we'll get into, I've started plant layout design. We're looking up in the top left corner. We have plant layout design. And how do we start with this? So we're creating an area for our plant, right? So we're going to create this area. We're giving it a definition of where it's going to go. I'm going to work on the fourth work cell, so I'm going to actually bring in an existing 2D drawing of the plant. I do this, we can bring in a DXF or a DWG file. I'm simply opening those from the computer, and I'll select that. There's some scaling things that kind of goes on in the background, but from this point, I don't have to do anything. I can just exit this, and then I have a 2D sketch. So this 2D sketch, what that's going to allow me to do, notice that I already have my other machines, but I've got these 3 cells down on the bottom left that are basically space reservations for future. So we can use space reservations in the plant layout. You don't have to have the machines. You can just create these little blocks, tell them they're space layouts or space reservations.
Yeah. Then also with just real quick with the 2D stuff, if we're building, so say you're working with somebody where you're building a line or whatever you're doing, you're putting something in and you're getting stuff from other external people. They may only have 2D AutoCAD or something, but you can still put their drawing in as a footprint and then keep on building off of what you're doing. So just not only your stuff, but if you get other stuff from other vendors and things like that, you can take advantage of that and still use it. But Jeff.
Cool. So we have our layout. Where are we going? Nope, it didn't start. Let's make sure we're playing.
Clicker not working.
It worked, but it didn't work. There we go.
There you go.
All right, I opened up the existing plant, right? And I have this open in Plant Layout Design. If you think about it, we can work on the work cells at different times. So I'm actually going to open up the fourth work cell that I had my space reservations for, and I can work on that. So imagine like in SolidWorks, you're working on an assembly or a sub-assembly. So we can do these in sub-assemblies. You can have multiple people working on different work cells at the same time, and at the end of the day, we're gonna put them all together, right? And we're gonna put them in the factory flow. So now what I'm going to do is I'm going to search for my OMAX machine in the database. I'm bringing in an existing product. So this is going to allow me to do that. So it's going to open up in its own window. So notice at the top I've got several windows open. I can switch back over to my fourth cell plant. Before I do that, I'm going to look at the full feature tree. Now I'm back in the fourth cell. Now what I want to do is tell it I'm going to insert an existing product into that cell. I can go back over to the other tab. I select my OMAX machine, and then I go back to my fourth cell, and it drops it in there. So we can manipulate where it is. I can manipulate what's there. So if I don't want the control box on the side, I can turn around. I can hide my control box on the side. And then to move this part around, we can have our origin snap directly to it. So when I select the product, that whole work cell, it's going to snap to the origin of that work cell. This allows me to manipulate where it goes. I can edit that position. So if I want to rotate it 90 degrees how I want, I can rotate it that way. I can put in any coordinate system that I want, or I can simply escape out of that and I can drag this to where I want it to go.
Yep.
Right, so we can just move it around pretty simply. Go to my top view, and I'm going to drag it up into one of my boxes.
And if you have any coordinate systems that you have in SolidWorks that you want to bring across, or planes or sketches that are consumed, you can bring those through as well. So if you want to, like if you have something there to line up, or you have certain offsets that you have set up or whatever that is, or coordinates that you created, you can bring those through and turn those on and off too.
Right. So now I've got that positioned where I want. We can go back to an ISO view. So that's bringing that in. The other things that we have in our system, so that's bringing in a product that we created. There's also a library or a catalog, it's called for 3D Experience, of other objects that are used into a plant. So we have, did it not go again? No. Okay. So in the catalog, there's pallets and conveyors and forklifts and cars and trucks and a Corvette and a Porsche. And I don't know why those are there. I didn't put them in this plant, though. But I'm going to select a pallet, and I can simply drag and pick a position. So I'm picking the corner of the captured 2D. I can go to the local coordinate of the pallet, and this allows me to then snap that to that position on the part. So it's a really easy click and snap and drag. And notice here, I've got all these different definition sizes. I can change the size of the pallet. So a lot of the parts that are in the catalog are actually editable. So I can parametrically just change those dimensions and change the size of the pallet, make a different configuration of it. Works really well, really easy.
And you can bring your SolidWorks, if you have conveyors or whatever, you can bring that and add those to the catalog and add definitions to that as well. Just doing that with a customer, again, a couple of weeks ago from when I was training him 5 months ago. He forgot. We got together and he did it again, and he was like, oh, as soon as I started doing it up, I remember now, and he's just going through. So it's very, very intuitive once you do it, once you want to pick to set it up. It's very slick.
All right, so I've got my line. I went ahead and added 2 more machines. You actually have a tool in there where you can actually pattern, so you can create a pattern of the first machine. So I can just tell it I want 3 machines and the distance apart, or I can simply just keep dragging that one in and placing them where I was. Notice I also have a robot in there. So Don mentioned the robot programmer. There's some other tools that we can work with the kinematics of a robot if you don't have a robot programmer. That's how I worked with this one. But the catalog of robots also have, like he said, home positions. So if I bring in a robot from the system that has home positions, I can use those in plant, in factory flow, which I'll show that here in a minute.
And Plant Layout does come with the robot library. So it comes with over 20, now it's over 2,200 different robot models with all the kinematics in them. So it does come with that.
All right, so now I have my full factory. I've got 12 machines, I've got 4 conveyors, I've got workers, I've got pallets, all of these things in there. So what we're going to look at next is how this works, right? So I'm basically zooming in and out, just kind of giving an idea of how responsive it is. Really quick, flips around. I don't think SolidWorks would be that fast. I mean, in large assembly design, probably you could. But to me, it's really easy to do. You don't have to simplify your model, right? A lot of times you take this big assembly and you dumb it down for doing stuff like this. We didn't have to do that. We simply drag it and drop it in there. It's taken care of by the software. So we're not wasting time having to dumb down this whole model to have something that performs. So now we'll look at what other things that we're using. So we saw plant layout design. I'm going to show some factory flow simulation. So this is the part that I really like. I was in production planning. I wish I had this for many reasons. But our factory flow simulation, so what we're looking at with the flow simulation is the ability to actually see the product flow through your plant. So you can decide how many machines you need. What happens if I add another worker? What happens if somebody doesn't show up to work? I can do it live and say, okay, well, if this person's not here, if I have someone else cover that position, what does it do to my production? So I can do these things and not affect the factory flow or the floor, right? You can send workers on breaks. You can have scheduled breakdowns or unscheduled breakdowns, scheduled maintenance, all of these things in factory flow. So what we'll do is look at what it takes to set up a factory flow. It's really simple. So the first thing I'm going to do is create a factory flow. What you need is an end zone. What product is coming in? I click on the floor till there's where I'm coming in and what product comes in. I pick that out of my tree on the left. My next thing is like, where does it go from there? It's stored on a pallet, goes from the pallet to the conveyor, goes from the conveyor to the machines. So each of the 3 machines and then out. So that's my flow. So now all I have to do is go back. So each of those positions, it's smart enough, it knows what it's doing, right? It knows a pallet is a storage place. It knows a conveyor is a conveyor. It knows a CNC is a CNC machine, because those are kind of how they're defined when we set them up in plant layout.
In plant layout, we actually define things as a resource.
Yep.
So like tell that pallet that's for storage. We tell the CNC machine is a CNC machine, a conveyor is a conveyor, and so on.
Yep. Mine's working. Okay. So what we're doing now, so we saw the pallet as a buffer. It sees the conveyor. It automatically makes a transfer. So it's transferring the part along the conveyor, but we can set how many parts go on the conveyor, the distance between the conveyor, between each part, how many parts it'll hold, how fast it'll run, those type of things, and what product is on it. And then once we have the conveyor set, then the next thing is, how are we going to our machines? So it knows the CNC machine is going to change it, so it has a transform behavior. So I can edit that transform behavior. How long did it take to produce the part? So what's my cycle time for that part in the machine? That's simple to set up. We can change that. We set that, and then what product comes in? So this is a raw casting of a pump housing. So my raw casting comes in to the first machine, and it gets transformed into another part. So I pick this facing part, so it goes in and faces off the ends of the part. So that's the output. We go from that machine to the next machine in a flow, and we can do the same thing. So I'll edit the resource configuration, go to my transform, I'll edit my transform, put in my cycle time. Pretty simple to do. What product is coming in again? So this time I'm not doing the raw pump housing, I'm doing the one that we already machined and did the face off. So I'll go in and select that as my input instead. And then my new output. So you can define each of these steps manually instead of, like I could do my end zone and tell it what comes in, then I can define the pallet, and then I can define the conveyor, or you can do like I did the first time as I go click, 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 click. I like doing that and editing it because I know where my flow is. So then I'm just assigning what happens in each of those flows and how long it takes to do it.
Yeah, it is much faster to go ahead and click through your sequence or your process, so you don't forget to click on something when you're doing it manually. I do the same way. I go click through and then I go edit what that needs to do.
All right. Last one, and then we have the flow between the things.
And then, because how many people here can left mouse click with their finger, right? You guys saw that, so you guys have been trained, right? So you guys can do this. No, so with all of this, what's nice is that it's very intuitive. You know, you can go into the dialog box, and then if something's not working, You just edit that and kind of what needs to move, what doesn't need to move, does this need to stay? It's very kind of intuitive that way where, because you'll see something if you get it wrong and all of a sudden you see a part going off the conveyor or going out in space because they're like, oh, I didn't tell it to stay there. So then go back in and fix it.
Right, so now we've got this set up. Now we're going to assign resources to the flow. So what this is basically what is moving the part. Is it a person or is it the robot? So in this case, we're using this robot to move the parts from the conveyor from one machine to the next machine to the next machine, and then it goes out to another workstation that's part of the full plant. So I'll go in and assign a resource to the transfer between each of those. Really, I'm just picking on the arrow between the machines and then telling it what resource is doing that, right? So I just pick the robot. It could be a person. We have those as well. A worker, an AGV.
Yeah, and if you had a group of, if you had a group of people or robots that can go to a station, you then assign it to like a resource pool.
Right.
And then that group, that is essentially a group of who can go where.
Right. So we talked about home positions. I'm going to show a little bit of that on each of the machines. So I have home positions that are set up for the robot. So somebody used Robot Programmer to program this robot, and they have these home positions. And as in the plant factory flow, when I'm going through, I can tell it, okay, my home position 1 is picking up from the conveyor, 2 is going into machine 1, 3 is going into machine 3, and so on and so on. So I think I'm on the third one now. Second one, go into the third one, okay. So we got that. So just to summarize the resource configuration, this is showing the resource configuration for the whole plant of cell 4A, right? So this is my work cell I just set up. We see each of the product zones. We have each of the 3 machines. There's the conveyor, the robot. You can look at all the different behaviors. It's a good way to check what's coming in, what's going out on each of those positions. Pretty simple to do. So now that we have cell 4 created, we flip back over to our full plant and everything's in there, right? We did cell 4 all by itself. We did all the programming all by itself, and we have the rest of the plant. All we do is add a connection between the out of cell 4 going into the rest of the plant, and we have our full layout. There we go. So we're going from, we have a worker going from putting the things from the pallets into the conveyor, and it goes from the conveyor through the cells into this other machine right now. Those are called space reservations, those blue blocks. It's if you don't have your 3D models, all of those things, you can set up the whole plant with little blocks or cylinders, right? So I'll turn it on. We can see the worker moving. Right now it's at a slower speed. I can speed it up so that we can watch the worker on coffee, and the robot's moving around. So it goes to each of the home positions. So when I select any of my resources in the tree, it gives me an idea of what's going on with that resource, right? We can see that it's working when the green arrows are going. It gives me an idea of what it's doing. We can look and see what the downtime is or what the wait time is for each machine or each worker or each resource, right? You can actually click on those. So we see, like this one that I have selected, the worker, how long are they idle, right? How long are they being used? Are they utilized 100%? Or are they being overworked? Same thing for the robots, all those as well. Pretty nice. You can run real time. Basically, you speed things up. So you can run 8-hour shift. You can run it for a year, right? But you just speed things up and you can see what those resources are.
Yeah. And once you learn the colors too, the color key, that those colors that you saw there, that's letting you know green, it's waiting, it's what it would, if it's waiting for something, it's a different color. So those would kind of help you see what's going on when you're watching an animation as well.
All right, so the output we get, so global statistics are basically all of the output for all the stuff to crunch your numbers together and everything. So you have each of the machines and what their input, what their output was, any downtime, those type of things. We also have for our workers, robots, conveyors, all of those data points. The workers are really cool. You see how far they traveled carrying something, how much time was spent moving, how much time was spent moving empty. Same thing with the robots, the workers, everything. So it's really good data, a lot of information to take in, but it's very helpful to see all of this in what if scenarios, right? If I just want to add another machine, what if I replace this person with a robot? Fun stuff. Now we'll talk a little bit about the drafting application. We'll let Don talk more 2D. The CATIA drafting is part of also, you get that in the plant layout and factory flow role, so.
Sure. So yeah, so what the CATIA drafting app lets us do with, that's included with this, it lets us to create 2D drawings if need be. So maybe whoever you're working with wants to see a 2D drawing, we can do that. So we can build, with the drafting, we can create views, projected views, just essentially think of the same thing what you do when you do a SolidWorks drawing. So you can bring in a top view and then from there project your views off of that. You can dimension, you can annotate, you can do all those kind of things. And then from there, you could save that out as a DXF, a DG, or even a 2D PDF as well, whatever you want to do. And then when you do this, it has the ability to, of course, whatever you change in the layout, when you go back into the drafting tab, it'll update accordingly if there's been changes, just like everything else. Okay.
Right, like so if you look at this 2D drawing, it's basically capturing from the top view of your plant layout onto your print. So remember the original layout that I brought in had those work cells that were placeholders, and now there's machines in them. So it just recaptured everything that I brought in right then and there. So if I make any changes in the plant, I recapture it. I can move the machines around and recapture it, and it updates my drawing for me.
Yeah. If everybody's familiar with like how MBD works, model-based definition, like you kind of create those views, it's doing the same thing. It's creating those views for you on the drawing. And then it'll gives you a tree, just like your SolidWorks, it'll have your sheet, and you can change that to whatever you want. And you can create multiple sheets as well. And then each one will have which view you're doing and what the scale is and all that kind of stuff. So very similar.
And that's kind of what we just.
And this one too. So I can export this out. So if you just if you look at the screen real quick, it lets you know, just so your reference, you can then save that out as a 2D file if you want to. You can also export out as an option. So you can do a file, like you can do a save as, or you can do an export. It depends on what you're trying to do for that. And you, like I said, it doesn't allow you to save like a version of a DXF or DWG, but I know I can open it up in 2008 AutoCAD. That's the oldest version I had of AutoCAD. I had the draft site too, and it opened up in 2002 as well, so I'm assuming it would open that as well. So it kicks out a pretty generic version of it. Cool. All right. Oh, point cloud. So here's, so what you can do is you can get your manufacturing facility or whatever you're doing, you can get that 3D point cloud scan. So we have a ability to do that. We've done that with other customers that go ahead and take, this one I think is right around a little less than 100,000 square feet of this facility here. And then if you look here, it still has a roof on it, with the view you see, but that's their CAD data on the right-hand side, and then that was the 3D point cloud scan. Because we had scaling questions. They're like, this isn't scaled right, but you know what was wrong? Anybody want to take a guess their drawing was wrong? Right, their drawing was wrong all this year. So they had 4 feet, their pedestals and their gantry machines were 4 feet off. So they would have built stuff in the wrong spot. And they were buying a stamping machine that they were putting a whole cement platform in. That would have been off by 4 feet. So the 3D point cloud data was crucial for them. So these are the different ones we can import. Just to give you an idea, we can do multiple different ones. And whoever, we work with different types of machine or different types of scanners. And all these scanners, whatever they bring in, a lot of them, their software they have, they can convert whichever we need. So, but they're very good with that, with the data for sure. And here's kind of just to kind of show you some of the stuff that we've done. So this is a facility, and this is what the 3D point cloud scan looks like when they scan it. So there's the data brought in. And we work with them. This is kind of like the top view of what you saw. So this is all the existing equipment, and they're going to do some modifications. So what we did is we cut out what was there, and we put in, this is SolidWorks that goes in here. What they did in SolidWorks, we brought it inside here to get everything manipulated and make sure that we had everything, or make sure that they had everything designed the way they wanted to in the right sizes. This is just kind of an ISO view of it as well. So we had to cut that out, and with that as well, they found out where they had their sealing machines, those were off by probably about, I thought we were like 30 some inches. They were off one way so that would have been, but the point cloud was right. So they moved the stuff in their AutoCAD stuff, and they moved it in their SolidWorks for their layout there. So it's like bringing two together, sometimes three different things together into one to manage it. And then I'm just showing here, everybody always asks, can you measure? Yeah, you can measure.
Yeah, measure in there.
So, and then what that was is we wanted to make sure they had 42 inches, I think I remember, for a walkway. They needed to make sure that someone could get through there. And if we wouldn't have had that, yeah, we would have been off 30 inches and they wouldn't have had a walkway. So I'd have been in trouble. And I think that's it with that. You want to finish her up here?
Yep, so easier, faster, better plant layout with 3D experience in SolidWorks. So we saw the connection of SolidWorks and 3D experience manufacturing DELMIA products. Our factory flow, plant layout, factory simulation, drafting apps that are all part of it, able to actually work with the SolidWorks assemblies, all of those things as well.
Yeah, and that other facility with the 3D point cloud, that was like a recycling center. And that other machine was like what do they call it? Like a plunger that compacts everything down. And they were trying to increase efficiency. And if they would have, again, they said they would have been off, they would have, all those new things they bought, they would have had to move them all again. So it was kind of fun there. And then you're like, I'm trying to remember. And he went back to look to see who had to change the drawing, and it was his brother. So he couldn't say anything. So
different offers.
Yeah, I can talk about this one. So there's offers, which we call 3D Experience Works offers out there, and they package these together. So if you see on the right-hand side, there's a virtual factory standard, and that comes with 3 roles. SolidWorks put them together. We should say Decimal put them together. So you have Plant Layout Designer, Lean Team Player, and 3D Creator. Those other 2 are roles as well. And so with the plant layout, you get plant layout like you saw. Here with manipulating, creating different, assigning resources, like telling it it's what type of machine it is, what type of behavior it has. And then from there, if we want to do the factory simulation that we showed you, applying times and those kind of things, then you get into the professional that has the one below, the second one down where it says Factory Simulation Engineer. That's the professional, and it comes with those 2 other apps as well. So they kind of package it together almost just like you use SolidWorks Professional and like SolidWorks Premium. This is very similar to something like that. And then what you see what is Lean Team Player? So Lean Team Player allows you to, it's like a virtual whiteboard. You can assign, you can hold meetings in it, you can put up announcements, you can put up activities. You can assign people things that they need to do. So those reports that we generate, we can say, here are my reports. You can mark it up and say, we're only getting this much out of here, we're only getting this much out of here, and give it to the team. Invite whoever team members you want to. and then you can assign something and say, hey, we need to address this, and then we can then use that to have meetings together and then work on things that need to be done. And also you can also tie it to, like if it needs to have an approval or someone needs to approve that, we can tie that to other roles that are out there that says someone needs to approve this before we can move forward. Okay? And the other one is a 3D creator, which is, it comes with XDesign. So it's a design software that's cloud-based that you can use. So if you know SolidWorks, you can do XDesign.
Yep.
So just an FYI.
Cool. Questions? Yes, sir. Routing and piping, not in plant layout. Yes.
Yeah.
If it's a SolidWorks assembly with all the routing and piping, you can bring that in to the plant layout. I don't believe
What was the
the PID. That's the files for routing and piping and.
I don't think so, no. What is it again? No, I don't think so, no. No, but there are, there's all kinds, everything's scalable. There's all kinds of different roles out there. It may be a role that, there's all kinds of things out there. There's Geovia, which is like building tunnels. There's Biovia, which is biometrics for medical. There's all kinds of different things, but I would stop by the DELMIA on the playground in the back there where that is and talk. There's all kinds of people there representing, and they would know for sure. But there's routing that's in, but it's just nothing we covered here today.
We had another one over here.
Just to answer that question, I think there's somebody else out there before.
Yeah.
I forgot.
Okay.
Yeah, there's like an add-in for SolidWorks with the pipe. Yeah. Yeah.
But my question is, you mentioned 3D point cloud. How do you do that? Do you have like a scanner or something?
Yeah, it would be a LiDAR scanner that you go around, and essentially the one that we use it's a harness that you kind of puts on them, and then he just kind of walks around and it just scans everything. If you go back a few, to where it gets the overall, the one where we're comparing the two. Go back one more, right there. So if you look on the bottom right-hand side, those are actually van trailers that are backed up to the dock when he was there scanning. And then you can go ahead and then all the like excess that you see, like the dock trailers, there's an extract command that I can go in there and cut that stuff out and remove it if I want to. And then same thing with the roof, like you saw the other one that had the SolidWorks stuff. The first thing I normally do is go in there and do an extract, and I cut like the roof off and then hide it. And then I can always turn it back on, but then it's easy to see, because when you scroll in, the more detail you see, it gets more detailed.
Yes, sir.
To determine how many machines you need to optimize your efficiency and so forth, as a DELMIAWorks, is there a way to push that into DELMIAWorks to automatically add your work centers, and create basic bombs and the cycle times based on what you estimate?
So do the DELMIA, the other factory stuff, right?
Yes,
The
yeah.
production.
So you can dump this into you can dump this into MES stuff. You can dump this into there. Yep, and keep track of that. And then you can even take the data that you get from MES. So you already have data for that. You can dump that in here and then use that and then go back and forth. And that allows you then to generate those separate reports to say, this is what we're doing. This is what we think we can do. Mm-hmm. Anyone else? I do it in every one. Bueller.
Oh, yeah, you do. You did it in the last one, too. Yes.
So there's no issues with any of our machines that we already have designed in SolidWorks, bringing in
Yeah.
Into 3.
Yep. 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 And then if you want to, you can like say you do have like a design in SolidWorks and you have like a simplified config of it. If you want it, you can just bring that config in and just that one. If you want to. Yeah.
same thing with all our other conveyor.
Yep.
things
Yes. Yeah.
Yes. Right.
Right.
And that's why I was working with a customer a couple weeks ago. He did a bunch of conveyors, and they had some new ones now that they designed. So we were going back in there and we were setting up the parameters, because then it makes them. Because then when he brings one in, he puts the parameters in there, and then he can update it, and then it'll add. And the one he did was a belt, so he had a belt for conveyor. So he was changing the belt length, the width, the height of the frame, the legs, and that. And then so you can do that, and it makes it interactive right away. And then that way he just brings one in, and then he can change all those parameters.
Any performance issues with a 300,000 square foot with 20 machine lines in it?
Not if you're doing, when you get into point cloud, it depends how big the point cloud is. That can, right now, we can only store that right on your drive.
From your local.
So you're gonna need quite a bit of drive space, but it's slated for 26. Sometime in 26, they wanna be able to save your point cloud information to the cloud, so you don't have to have that, right? And then also with point cloud stuff, 32 RAM works, 64 is just better. I mean, it's just gonna, you can scroll in and out faster. And again, this is with point cloud, so we get into the point cloud facilities, but we have customers, but there is a way for us to break up the point cloud. Like one of the customers that we broke it up, and we broke up all the bays, just because the bays, sometimes they do talk to each other, meaning like when it needs material from being delivered, then we have that layout set up. But then also if it's just one area they're working on, that they just address that bay, and then that way breaks up the point cloud as well. So there's different ways to do it. You can cut it apart and do it that way as well. And also whatever you cut apart, we've done those, some things that they don't have the model. We actually made that a machine and then assigned, whatever the rate is for that machine, because what they have is it's old too. It's a stamping machine, but it's got something else on it. But anyways, this machine's so old, when they scanned it, we just cut it out and made that a machine, and whatever, how many pieces come out of that goes into the production line. It's like, I think for a radiator or something. But anyways, so they didn't have anything like that. So you can do that and make those, and put those in your, like a bookmark, and save those there, and you can always drop and drag them in any other layout.
Okay, all of our files are also in PDM, so it plays nicely with PDM.
I wouldn't say it's like two twin brothers fighting over a steak. Someone's gonna win. So what you have two PLMs. So when you try to save directly from PDM into this, it shuts the door on you and says, I don't like you. So we got to do a different way. So how right now the process or the workaround for that is, so if you want to keep running PDM, you want to bring stuff in here that way. We work with some customers. What they do is they pack and go out that assembly, and then we bring it in. And then if there's changes or whatever that is, what they've been doing is if there's changes, they'll save out like the parts that changed or the sub-assemblies that changed, they'll pack and go those out and then bring them in, and then we can replace them that way. And they have to do something when they save out like a underscore, like V2 or R2 or something, and then we can just replace them. You could leave it the same name, but this way they know it's been replaced. It's just more of a management for them that way. But yeah, and it's not just it's just not SolidWorks PDM. There's other PLMs that we work with customers that it's one wants control and the other one's not having it. Yep, but yeah. But you can we do have some batch things that we can import if you're going from one to the other and you're going to use, the platform PLM for that.
All right.
Talk about the robot library. You don't have to have the robot simulation package necessarily, right? Just bring it in the geometry.
Right. Yeah, but you can bring in the geometry. Yeah, so it comes with, when you purchase, it does come with a robot library there. You can choose to do how you install the robot library. You can do per brand, or you can do per robot, or you can do the whole library. Because each brand is in its own individual folder. So you can just bring in certain models. Because if you're going to bring Fanuc in, Fanuc's got almost, I think they have a little over 600 on now. And so there are quite a few. Mm-hmm. That way you don't have to search all over the world on the internet, or whatever. Because and then also if you're a customer and you don't find yours in there, we can we have you talk to, or tell you who to talk to or wherever to talk, because you're the customer, we're not. So they'll give it to you more so than, you know, and if they give it to you and don't have the kinematics, you can send it to us, we'll get your kinematics added if it's new. Because we just had an issue with a customer a couple weeks ago. They were looking for a 165 robot, and we were like, I really don't think those exist. And then I called the Fanic guy, started laughing, and he goes, those don't exist. And I go, that's what I thought. So customer goes, oh, well, I meant 125. And I said, okay. So, but again, it was just it was whoever gave it to him, we couldn't read his writing. But, you know, but then again, what's nice with that is we can tell you, like I told him to use a 215 because it was very similar, just a different payload, but everything was the same except for the payload. So use that in the meantime, so it was not a big deal. And just to switch out, you just replace, there's a thing you replace and you replace it. Mm-hmm. That's what makes robot programmer good about this different subject, makes robot programmer great, is you can put a KUKA in for a Fanic and you just replace it, and then it grabs all your location points that you had. Only thing you really change if you have different callouts for like when you start or end a weld, you have to change that with the translator in the actual controller. Other than that, you don't have to reprogram the robot. You just, if there's special, because Fanic talks to the welder different than KUKA does, but everything else will translate across, which is nice. So you don't have to be brand loyal. Meaning, especially the way things are today, we had customers that said they wanted these robots and they went to ABB because ABB could deliver them in 6 weeks. And whoever they were with, I forget who it was like 7 months. And they're like, no, we have to have all this stuff shipped by April, you know? So yeah. Yeah, and they didn't need a KUKA or a ABB guy to program it. They just had the same robot programmer guy that programmed all the other stuff. So it was nice.
We can switch back over to that.
All right. Any other questions?
There we go. Cool. Thank you, guys.
Thanks, everybody, for coming.